with missions. Let me share my screen. There we are. Okay. So as I said, welcome product demonstration judges. In this presentation, I'm going to go over the specific mission responsibilities of being a product demonstration judge for 2025 in the Scout class. There's also a general presentation where I go over some of the general responsibilities of being a product demonstration judge, kind of how to run the mission station, but this is specifically about the missions that the teams are doing underwater. Okay, so before we dig in, just so you know, there are video fly-throughs. These are little animations that show the ROV doing all the tasks. Those are a great resource, and you can check these out. And I highly recommend that when you check them out, maybe print out a Scout score sheet, a Scout product demonstration score sheet, which you can get on the website. Same place you find these videos. Not the same place, but on the website. And you can go through that score sheet as you're watching this video and just look at how you would score this. Okay, so let's start looking at the specific tasks. And task 1 is shipwreck, spotter buoys, and flying fish. For shipwrecks, they're going to be picking things up to determine the identity of a shipwreck. They're going to find out some stuff about it. For smart buoys, they're going to replace a damaged thermistor and install a PCO2 sensor. And then for task 1.3, lake acidification and invasive carp, they're going to collect a water sample. They're going to do some tests on that sample. They're going to do a pH test and a dissolved CO2 test. And then they're going to get some eDNA data and do some eDNA comparisons. So let's jump into it. For the shipwreck, they're going to be figuring out what the shipwreck is by picking up some of the things. By picking up 3 things, they're going to be picking up a dinner platter, which is a big structure over here. And on the bottom of this, it's going to have a date, and that's the build date of the ship. They're going to be picking up a bottle, and that's going to have the home port of the ship printed on it. And then they're going to pick up a cargo container, open it up, look at the color inside, and determine what cargo it is. So again, as we move on, as I said, the dinner platter is going to have a build date of the ship printed on it. The bottle is going to have the home port of the ship printed on it. And the cargo container, they can open up, and you can see in here, this has some red PVC inside it. So red equals bricks, and they would use that, the cargo, to identify the shipwreck. So once they get all 3 of those from the build date, the home port, and the cargo, teams can identify the shipwreck. So there's going to be a shipwreck handbook on the table. It's going to be laminated. It'll say shipwreck handbook for Scout and Navigator on the front. And that's going to have all the necessary information about these ships that teams can identify which ship it is from these unknowns. Now, your judge cheat sheet should have the name of the shipwreck on it and all 3 identifiers. So you're going to know, of course, what it is. And since you'll probably be at the same mission station all day, your shipwreck shouldn't change. So, you'll learn it. But just so you know, it should be printed on your judge cheat sheet, which your regional coordinator should provide for you. And I will say that teams must have picked up all 3 things to identify it. Even if they could identify it from only 1 or 2 of the items, they have to have all 3 items up on the pool deck in order to identify the shipwreck. Okay, so moving on to task 1.2, the smart buoy, teams are going to be replacing a thermistor. So the thermistor is a long line. On the top, there's going to be a yellow float floating on top. And that's at the bottom, there's going to be a weighted base structure. And there's a rope connecting those two. And about partway up the rope, halfway, maybe less, maybe more, there's going to be a 3-inch pipe with a bottom on it. And in that 3-inch larger pipe holder, there is going to be a thermistor. And this thermistor is just simulated by some simple PVC with a number 310 U-bolt on it. And the first thing teams have to do is remove the old one. So there'll be one in there, just like this. And teams need to pull this one out, bring it back to the surface, and then there's going to be a new one on the surface that they need to put on their vehicle, bring back down, and they are going to drop it into here, and they will get their points. So, as I said, teams have to insert it in here. Now they can do this, I don't want to say out of order, but if they want, they can bring the new one down in one gripper, pick the old one out, pull it out of here, put the new one in, and then return the old one to the surface. So they don't have to pull the old one out, get it to the surface, put the new one on, put it down in there. If they want to be a little more efficient, they can bring the new one down, pull the old one out, put the new one in, bring the old one back up. And the other thing I want to say is these are identical. The old and the new one are identical. So the divers don't really need to replace the old one with the new one, as long as it is in here in a good way, sitting in this holder. The divers don't need to exchange these between mission runs. So the other thing they're going to do, so this is over in this is the base of the sensor, the smart buoy, and it's going to have this 2-inch PVC pipe with a 3-inch to 2-inch adapter. And on the surface, they're going to have this simulated PCO2 sensor. They need to carry this down, drop it in here, and when they do that, they are good. They get their points for installing that PCO2 sensor. Now, for both the thermistor and the PCO2 sensor, and pretty much everything they are installing throughout the mission runs, it needs to stay in there for the entire mission run. So once they drop this in there, if later they accidentally knock it out, or for this one previously, if this falls out, they're going to actually lose their points for putting it in there. So you can cross those points out or at least make a little note, but they can regain those points by putting it back in. So, if halfway through the mission, this falls out, falls out of the holder, you can let them know, hey, that fell out. You've lost your points for that, but you can go put it back in. And again, they can go put it back in. And the same for this. And generally, as I said, the same for most of the items. I believe all the items they're installing. If it falls out, if that connector comes loose, they lose their points, but they can get those points back by reconnecting it again. Okay, let's move on to task 1.3. The first thing teams are going to be doing is they are going to be collecting a water sample. And so our water sample is simulated by this pipe, a 1/2-inch pipe with a rope on top so they can grab it. And inside here, they can open this up. There are going to be 2 test tubes full of liquid, and they'll be marked, one for pH, one for dissolved CO2. And teams can get that. Now, you may have it set up where teams don't actually use the dissolved CO2. That one may not be in there. There may be just a separate water container on the surface that's a little more controlled, not going in the pool. So when they do their dissolved CO2 test, they can use that water. But as I said, your regional coordinator will let you know that if it is. Okay, so the first thing teams need to do, or one of the things they need to do with these water samples, is determine the pH. So again, they can take this vial, this test tube that has liquid in it, and they will test the pH of it. Now, on your table, you should have a little litmus test strip container there that they can tear off an inch or two of litmus paper, dip it in there, and get the pH. But teams might also have their own device to measure it however they want to do it. That's fine, as long as they're measuring the pH of that. Now, you are not looking for a specific pH number, so you're not looking like, oh, this sample is 4.38 pH. Really, we're looking for an acid or we're looking for a base. So, as an acid, it's going to kind of turn orangish in color, orangish yellow in color, and it's already kind of yellow. So if it doesn't change, it's an acid. And if it's a base, it's going to be kind of a greenish to dark blue to black in color. So again, we're not looking for a color, just looking for acid or a base. And so one of your responsibilities as a judge is going to be to refill this test tube if they empty it out or dump it out with water. So somewhere near the station, it might be at your station, might be somewhere near it, there should be 2 buckets, one labeled acid, one labeled base, or maybe one labeled A, one labeled B for acid and base. And just between missions, refill that test tube with whatever you want, an acid or a base, and put it back in that water sample and get it to the diver to get back down to the bottom. Okay, so for the dissolved CO2, They're going to be doing a test kit. So on your table, you should have a big blue test kit that's carbon dioxide. And again, we're not going to be looking for a specific number. We just want to make sure that they run through this test and do the test properly. We're not really looking for a specific number. You're not looking for, you know, 15.2 parts per million. We're just looking at the process. So from this presentation, if you go into the presentation itself, you can click on a written description of the process, or there's a video of me running through the process of what they have to do that you can look at. But it's actually pretty simple. So they are going to fill a little beaker to the 20 milliliter line with a sample. And again, as we go back, this does not, the dissolved CO2 one doesn't really have 20 milliliters in it. So again, there might be a different reservoir of water at the top that's more controlled that they want to do this with. But they're going to fill the main beaker up to the 20 milliliter line. Then they're going to put in 2 drops of reagent A into that. Reagent 1, reagent A, 2 drops of that go in there. And then they're going to fill a little syringe with reagent B. And then they slowly, a drop or 2 at a time, put that reagent B into the beaker. And when they do that, it's going to turn red. But as they swirl it around a little bit, that red should disappear, kind of turn pink. And they keep putting drops in until that red pink color doesn't disappear. So the minute that they can see that after swirling it around, it's still any shade of pink, that's what we're looking for. Then they'll give you a number, but we're not looking for a specific number. We're just looking for this process. And again, we do want to see the process a couple drops at a time. We don't just want them to shoot in all 50 milliliters or whatever of this reagent B and say, yeah, it's red now. We want them to do it a drop at a time. So as I said, we're looking for the process. Okay, so also once they bring up the water sample, they're going to have access to some unknown eDNA. So when they bring back the water sample, it does have to come up on the table. There's going to be a laminated sheet with 10 unknown eDNA samples on it. Also on the table, there's going to be an eDNA handbook with 2 known species of invasive carp, their eDNA on it. And essentially, teams are going to compare these 10 unknowns to the 2 carp that they're looking for. And so each of the unknown samples of those 10, only 1 is going to match up with one of those. So it won't be 0, it won't be 2. 1 is going to match up with one of those 2 known carp. And once they get that, they are done. And so essentially teams will tell you that. For example, if they find out, number 5 is a grass carp, they're going to tell you number 5 is a grass carp. But the nice thing is you're going to have this on your judge cheat sheet. So whatever eDNA here, it's going to have a sample at the top. It'll say like, hey, unknown sample B. That should match up with your cheat sheet. But again, if, for instance, a team tells you number 5 is a grass carp, your judge cheat sheet will say, hey, if you have unknown sample B, unknown sample number 5 is going to be a grass carp. So that information you will have. And so here's kind of what teams are going to be looking at. So this is unknown. This is an unknown sample, lots of random numbers. And this is what's going to be in the handbook. So again, the same thing, although I don't think this one actually matches up to the grass carp, but I changed this name. But anyway, you're going to see that, all these match up, and it should be pretty easy for teams. We are not changing, one letter. Whoops. We're not changing one letter somewhere down in here to try and trick them. Generally, if they look at the first 5 or 10 base pairs, if they match up, the whole thing's going to match up. If they don't match up, it's not going to match up. So we made it pretty easy for the teams. But again, you have all this information in your judge cheat sheet. Okay, so that's it for task 1. Let's move on to task 2, marine renewable energy. And it's producing power. They're going to connect a solar panel to the grid, and then they're going to protect the base from corrosion. And then they're going to monitor environmental impacts, which is essentially just collecting some species and then placing a hydrophone down there. Okay, so let's start getting into task 2. And the first thing teams are going to do is they're going to be retrieving a power connector that they're going to then plug in. So the first part of this is retrieving the power connector. It's going to be down there on a little platform. Teams are going to pick this up and they get points once they pick this up. So picking it up means it's no longer in contact with the platform, but not just knocked over off to the side. It needs to be under control of the ROV, being moved around by the ROV, and they get points for that. And then they are going to insert it into this port, but the port has a cover that they need to remove. And my guess is a lot of teams will remove this cover of the port before they go pick up that thing. And that's fine. They can do this in any order they want. But they need to remove this cover. That'll open up this hole. And then they need to insert this in there. Now, if you look, the end of this, there's Velcro on here. And in here on this wall, there's some Velcro as well that they can make a Velcro to Velcro stick. But if they don't, if they get this in there part way and you're not sure, hey, did it really make a Velcro to Velcro stick? That's okay. Give them the points. If it's in there when they release, ROV drives away. If it's in there, they get points, even if it's not quite all the way in to get a Velcro to Velcro stick. But again, if this comes out at a later time, they're going to lose those points until they push it back in there. Now, the other thing I want to talk about is this cap. It is considered debris. So it either needs to come out of the pool or it needs to be on the ROV when time ends. It can't be laying on the bottom. Otherwise, that would be a penalty. Okay, so the next part is removing an old sacrificial anode and installing a new one. So this is the old sacrificial anode on the left here, and it has a very small bit of Velcro. The larger one has a larger square of Velcro, and the old one's going to be down there on a structure. They need to pull it off, bring it back up, and then they need to bring this new one down and stick it to Velcro stick. And again, they can do this in any order. So if they want to put the new one on first before they pull the old one, that's okay. Or they can bring the new one down, pull the old one, put the new one on, bring the old one back up. But it is important. Well, here you can see the base structure this is where they'd put it, and here's one on there. But what's important is that the divers do get the old one back on there because as you look at this, with this small Velcro, this one makes it really easy to pull off. Teams can pretty easily pull this off. Now, the larger Velcro makes it easier to connect. They have more surface area just to connect, but it's also going to make it much harder to pull off. So just make sure you have the divers substitute out this one with the small Velcro so it's easy to pull off, and this one comes back up to the surface for teams to take down, which is easier for them to attach. Okay, so we're going to move on to mitigate corrosion. Let's see. Okay, there we are. So on one of the legs, so you can see here's a leg with the black Velcro for the previous task, but this one over here is going to have 3 red dots on it, and this is corrosion that they need to apply a patch over. So it'll be down there visible to the teams, and here is the patch. So the patch is a larger T cut in half lengthwise. There's Velcro on the inside edge of this. These dots are Velcro as well. And they need to carry this down, and they just need to get a Velcro to Velcro stick. So all 3 dots don't have to be covered on this one. Yes, all 3 dots got covered, but as long as there's a Velcro to Velcro stick that this is patch is holding on there, that's good enough. They don't have to cover all 3 dots. If they're only covering half of 1 dot and 2.5 dots are visible, that is fine. It's a successful patch. And again, this does need to stay on the full time. So if they do barely get a stick and it falls off later, they lose their points, but they can get those points back by reinserting it. Okay, so the next part of this task is all about collecting organisms. And the first organism they're going to collect is a polyp stage jellyfish. So the solar panel array over here on the right, this is going to be floating on the surface. And around the bottom edge, there are going to be 8 holes, but only 6 of them are going to have these in it. And these are polyp stage jellies. They're just little pipe cleaners that are twisted together and inserted into those holes drilled around the base. So again, when a team gets these, just hand them back to your diver and have the diver put them back into the holes there, and there will be 6 of them. And so teams must collect at least 4 of them. They can collect more. If they get 4, they get full points. If they get 1 to 3, they get partial points for this. And collecting means putting them on the surface side of the pool. So essentially, once they're on the pool deck, they get points. So the next task is collecting a Medusa stage jellyfish. And teams are collecting this from midwater, and we're simulating our jellyfish with this water wiggler toy. Pretty neutrally buoyant, comes up slightly, but it's kind of a soft-bodied creature. Now, it may have a little bit of additional weight to make it quite still positively buoyant, so it rises up, but a little less. So this jellyfish, this Medusa stage jelly, is going to be in this holder at the start of the mission. So divers put it in here and just push this so the cap is on it. And then teams are going to come along. They're going to pull this. That's going to release this water wiggler jellyfish to float up out of here. As I said, it's positively buoyant. And once it's out of there, teams need to collect it. Now, what they can't do is teams cannot set up a capture device over the container. So before they pull this, they can't put something here to capture it. The goal of this and kind of the backstory of this mission is, hey, we want you to gather something from the water, but we know that teams might want to do this on their time, not from the start. So we're going to have this so they can release it into the water column whenever they want. But once they do that, once it's released out in the water column, then at that point, it's like, okay, now you drive in and collect it. You can't set up anything to collect it as it's coming out of its little holder. The other thing to note is that if the jellyfish rises all the way to the surface, that's fine. They can still grab it from the surface, no penalty there. It might just take them some extra time, but that is fine. Teams can collect it from the surface without penalty. And so for Scout class, which we're dealing with here, they can collect it by any means necessary. If you're looking at some of the other competition classes, the higher level competition classes, there are some restrictions on how they can collect this jellyfish. But for Scout, any way they get it back to the surface side of the pool is fine. So if they push it back and have someone grab it once it's within reach, that's fine. If they have a net that they kind of get it in, that's fine as well. As long as they get it back to the surface side of the pool, put it on the pool deck, they get their points. Okay, the third thing they're collecting are fish species, which are simulated by ping pong balls. So again, these are going to be inside that square that has the polyp sage jellies. So floating in here are going to be 6 ping pong balls. Again, they need to get at least 4 back for full points. If they get 1 to 3 of these back, they get partial points. And again, collect them however they want. When they put them on the side of the pool deck, they get their points for that. Okay, the last thing in task 2 is teams need to deploy a hydrophone. So this hydrophone will be on the surface at the start of the mission station, and on the bottom there's going to be this yellow square. Teams need to carry this down and set it all the way inside the yellow square. So there's 2 things here. It needs to be upright, so it can't be tipped over, and it needs to be all the way within this yellow square. When they do that, they get their points. Now again, if it comes out or gets knocked over, they're going to lose those points, but they can put it back upright, get it back in that square to regain those points. Okay, and that is it for task 2. We're going to move on to task 3, mate floats. And teams must create a float for this. The float must do a vertical profile, which is go from the surface down to the bottom and back up. It's going to be collecting temperature data along the way, and then companies are going to graph that data. So the first part is the team is going to design a float. And essentially, if they have a float, if they show up at the mission station with a float, they should be good to go. They get their points for building one. Then teams are going to deploy it in the pool. They can just put it into the pool by hand. And once it's deployed, it should create a vertical profile. Now, this year, a vertical profile is defined as a float being on the surface, so floating on the surface, and then goes down, touches the bottom, and then comes back up to the surface. And that's a vertical profile. Now, teams are getting a lot more points if they do this autonomously. So autonomously means they are using a computer program. They're controlling this via an Arduino, a Raspberry Pi, or some other way on the surface, and they're using that to control the motor. So essentially that means the team hits a button, they start their Arduino program or whatever, and that float goes on its own down to the bottom, back up to the surface. And that would be autonomous. They get quite a bit more points. So manual is just them driving. They either have a joystick or a switch on the top that someone's pressing to go down, press it the other way, it comes back up. So that would be manual, and they don't get as many points for that. So the profiler float should have a temperature sensor attached to it, and teams are going to be getting 4 temperatures, and this can be done manually. This doesn't have to be done autonomously. So if the ROV is going up and down autonomously, there can be someone there at the temperature readout getting those readouts. And the first temperature they're going to get, or one of the temperatures they're going to get, is in the air. So before it goes into the water, or technically after it comes out of the water, they want to get a temperature reading in the air. Then they're going to get a temperature reading on the surface. And on the surface means that at least part of that profiler is at or above the surface. So midwater is somewhere between the surface and the bottom. So no longer touching the surface, no longer touching the bottom, but somewhere in between. Anywhere in there is defined as midwater. So even if it's only 10 centimeters underwater, if they get a temperature there, that counts as their midwater temperature. And then they're getting a temperature on the bottom. So that is when the vehicle, when this profiler is touching the bottom, they will get a temperature. And the temperature needs to be within 4 degrees Celsius. So you as a judge, you're going to have a MATE temperature sensor there that you can consult with. And actually teams are allowed to look at that when their float is not in the water. So if they want to do a comparison of their temperature probe with our temperature probe, just to see if there's an offset, like maybe theirs is reading 0.5 degrees C higher than ours, they can just take that into account and say, hey, you know what? Ours is reading higher than yours, so we're going to subtract 0.5 C from our readings to get close to yours. But again, within 4 degrees Celsius, it's a pretty wide range, so teams must be within that range, but you will have the official MATE temperature on that temperature sensor that you have access to. Okay, now the last thing is teams are going to graph their data. So if teams get those 4 temperature points, they're going to graph those as temperature versus depth. And the depth they can use is really up to them. So air, just anything in the positive range, 30 centimeters, 10 centimeters above water level, that's fine. Surface would probably be somewhere at or near 0 centimeters. Midwater, for instance, if they're in a 7-foot, 2-meter pool, maybe they call that 1 meter, 100 centimeters. And then the bottom would be 200 centimeters, 2 meters. But if you're in a more shallow pool or a deeper pool, just have them use the approximate depth of that pool as the bottom, and then midwater is about halfway in between there. So really the depth is less important. We just want to see 4 data points at 4 different heights, and those are going to match up to the data they got. Now, again, they should be graphing the data they got. Even if their temperatures were outside that 4 degrees Celsius range, we want them to do the temperatures that they receive. So even if they didn't get points for temperature because it was outside that 4 degrees C range, you still want them to graph what they got, and they would get points for their graph, even if their data points were wrong. Okay, now if a team doesn't have a float, or their float doesn't have a temperature sensor, or that temperature sensor isn't working, they're not getting temperatures back, teams can actually ask to graph some MATE data. So somewhere, either in your folder or on the table, there's going to be some MATE provided data for these floats. And again, it's just going to be depth and temperatures. But instead of just 4, there's going to be many, I think it's 12 to 15 data points that they have to graph. But teams have to ask for this. So if they ask for it, you can give it to them. But if they do ask for this MATE data, what they're giving up is they're giving up all their temperature readings. So they have to give up all their temperature readings, the points for that, because obviously if they got those temperature readings, they would graph that data instead. But if they want to give those up and also give up any points for graphing the data they collected, they can graph MATE data. Okay, so that is it for the missions. Again, just some basic stuff. I covered this in the general briefing, but I'm going to cover it here too. When you're done, add up the points in all the various categories, and then go through those points with the team CEO. Tell them what points they got, tell them what they didn't get, what their total score is, and if there's a discrepancy or a disagreement, deal with it then when it's fresh in your head, or you can look at the pool and go, Well, yeah, they did get that. Now I can see it down there hooked up or whatever. Don't wait to do this, because if they come back 2 hours later, you're probably not going to remember what happened. You're not going to be able to verify. So if there's any discrepancies or disagreements, deal with it then. And then, of course, help the divers reset the mission station. So as one judge is going through the score with the team CO, another judge can be helping the diver reset the missions. So that is it. As I said, if you haven't checked it out, check out that general briefing. It should be in whatever email you got from your regional coordinator with this. Should have been in that email as well, the general one. It's much shorter than this and just kind of some general stuff about running your station. And check out all the resources. As I said, check out that mission fly through. Have a score sheet handy when you do it, just so you can look through things and match it up. And if you do have questions, feel free to reach out to your regional coordinator. And if they can't help you, reach out to me. You can get my email here at the bottom, mgardner@marinetech.org. If you do that, if you do reach out to me, just make sure you specify that you are a station judge, because if I just get a question from someone, I may deflect that over to our forum board. But if you're a judge, I will answer that directly. So that's it. Again, thank you all for volunteering.